In this video, we're going to talk about rational numbers. And what are rational numbers? Well, quite simply, as it says, rational numbers are numbers that can be written as fractions. So what kind of numbers would those be? Well, they'd be things like this, for instance. How about if we take one we're all familiar with, 25 hundredths, 0.25. We know that that's the same as 1/4. Or how about if we take a whole number like 5? We can say that 5 is the same as 5/1. That's a fraction. Or how about if we took a number like -40? Well, we could say that -40 was the same as -80/2. That would be the same as -40. So that's what a rational number is. A rational number is a number that can be written as a fraction. And in algebraic terms, what that means is in the form of a over b, where b is not equal to 0, and a and b are both integers. And for those of you who don't remember what integers are, they are the whole numbers and their opposites. In other words, whole numbers, either positive or negative, are integers. All right, let's push forward. So in terms of the decimals that we get when we convert fractions into decimals, something like this example, 0.25 equals 1/4, or 1/4 equals 0.25, there are two types of decimal numbers that we need to concern ourselves with. The first are terminating decimals. Terminating decimals are ones that end. Let's just write the word down, make sure everybody knows what it is. Terminating decimals. And those would be things like this. Let's take 3/5, for instance, which is the equivalent of 0.6. Or how about 3/4, which is the equivalent of 0.75. Or something, for instance, like -4/100, which could be written as 0.04, -0.04, pardon me. All right. All of these decimals are decimals that end. In other words, they terminate. They don't keep going on and on. This would be different, say, than what are known as repeating decimals. And that's what I want to look at next. A repeating decimal, or as a decimal that does not terminate. And so a repeating decimal would be something, say, like 1/3. 1/3 is the equivalent of 0.333, and those threes will just go on forever. And we actually end up writing 1/3 as a decimal as 0.3 with a bar over the 3. And we write it over the 3 because that 3 just keeps repeating, and the bar indicates that that digit just keeps going on forever. Another example of this, pardon me, I'm going to push this up a bit, would be something like, say, 7/15. 7/15, if we convert this into a decimal, becomes something like 0.4666, and those 6's keep repeating. And we can write this as 0.46 with a bar over the 6. Another example of this type of decimal would be something like, let's do something a little wacky. How about, shoving this up a little bit, 49/33. And if we convert this into a decimal, it would become 1.4848, and that just keeps going on forever. And I could write this as 1.48 with a bar over the 4 and the 8 because those two numbers keep repeating. So these are examples of rational numbers, terminating decimals, and repeating decimals.